small story underneath. Ne? Every term will take on this form. And R will increase from 0 to 7.
It's a sequence.
So this is the generic form that it will be in. Okay? So what you're doing now to sort of what is that? Oh, okay. He says just how he's thinking. Okay. The NCR part. You can take out the NCR part. Why do you think?
Because we're not in this event.
Why do you think if we take out the NCR this part?
We want to find
It
out.
doesn't contain the variable 1 over x to the power 6. You understand? And the NCR part, this 7CR, is the coefficient that you find when you were using Pascal's triangle. Is it not so? So that gives you a coefficient. But we are interested in what term gives us 1 over x to the power 6. That's why we call it up. Okay? So that's why you see that he did not write it down when he was writing the piece, for example. So from here on, we are going to take only this part. We say 2 upon x cubed raised to the 7 minus r. I just want you to write down times 3x squared to the r. I say cancel the constants. No?
Yeah. That's why I did not write.
Right, but they have to be like, let's give the reason why that we are not writing them. Just for you to have the notes. You will have no impact on our term.
No effect.
Impact on our term that contains what? Contains 1 over x to the power 6. That's why you don't see me writing up in 7 CR step by step. This is the general way it will be. Every term will take on this form, every term. Alright? Whatever your R is, that is what you're going to do. Is it not so? Using your general term, you take A value, 7 minus, or n minus r, b value, so whatever that is. Every term takes on this form. But now, because we are looking for which term contains that, we can take out the constant. This is the constant, 7CR. Because it will have no impact on our 1 over x to the power 6. Because now we're only interested in finding our r. That is the next thing that we are doing. So, to find our r, I'm not only going to cancel that. That's not the only constant that I'm going to take out. There's also another constant 2 there, and there's also that 3 there. So eventually, I will just have 1 over x cubed, right, raised to the 7 minus r, times x squared to the power. You see, I cancel what? The constant. Because they will not have an impact. And here's now where your knowledge comes of indices. And you're going to obviously then equal to x raised to the power of negative 6. X raised to the power of negative 6 comes from what? So, we have got 1 over x to the power 6, which is the same as x raised to the power of negative 6. So this becomes x raised to the power of negative 3. There are many ways you can do this, right? Times x raised to the power of 2r equals to x raised to the power of negative 6. So the idea is to find that r. Because we have to use our r when you answer the question, when the question say which term before, right? We don't want to find the term. You understand? Things are following. We don't want to find the term. That is the trick. We want to find which term. Is it the fourth term, is it the third term, and so on. So our R will help us with that. So anyway, this is going to give up. And just be careful when you multiply out the right? Maybe you keep this as a what is it?
Negative.
Yeah. So this is going to become 3R minus 21 times x to the 2R equals to. Actually, I can now drop the bases, okay?
Yes.
So this is going to be 3R plus 2R minus 21 equals negative 6. 5R equals negative 6 plus 21, R equals to, that's 15. Yes? So R equals to 3. Now, you can answer the question, which term?
Yeah.
Right? So that's going to be T, which is 3 plus 1, which is therefore the fourth. Maybe you can write it like that. Term will contain this term. Right.
And we already calculated
You said what?
we also calculated the fourth term, which is 946 over.
You calculated.
We calculated.
Yeah, you calculated the
Interesting.
what term did you calculate? The fourth term. But the question did not want you to calculate the term.
Just like this.
In fact, when you calculate the term, you realize that you're going to have x 1 over x to the power 6 as a numerical, not numerical, but literal
What if
quotient.
I just say x plus negative 6 is still wrong?
Yeah, but let's give our powers of
Yes,
this
fraction.
positive. Yeah, positive
Fraction.
powers. Positive powers. Because you need to understand what exactly that means. Okay, so that is the step-by-step breakdown of why we do. Okay? Now, armed with all of this, I think we are now ready to look at prime methods. Okay.
Any
But are you,
volunteer?
no. First finish writing.
Any
Are you
volunteer?
done?
Any
Or,
volunteer?
but,
Show them.
yes, okay.
Show
You are not
them.
ready. Are you sure you are done?
Show them. So give me the number 2. Show them.
Why are you so happy to do let's just not take too long. He says he wants to do number 2.
We end up with the number.
You guys are complaining about 2B what? 2B. 21 over 2.
It's easy.
So who is doing question 1?
Yeah.
Angela is doing question 1.
I'm doing it.
It says
Show them.
in the expansion, I'm going to write down the expansion. You realize they made a little mistake there with 1B, right? They're saying the term which is independent of x, but it's supposed to be independent of A. So just a typing, so you just highlight it as well with the highlighter. That's why I got the highlighter here, right? So you just can take note. It's supposed to be independent of A. Right, so I'll write down the expansion for you. And then the question asks you to find the fourth term in the expansion, blah blah blah, A minus. What is it? I didn't want to talk. 3 over what? Raised to the 12 power. In ascending or descending? Descending. What does that stuff mean?
It's going down.
The powers of A is going down. Alright, just read
That's diffuse.
the expansion. Right, this expansion, if we were to multiply it out, blah, 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 Pascal's, whatever, whatever it is, NCR, in descending powers of A. So powers of A are decreasing when what happens?
Decreasing towards.
Towards what? Towards A to the 0. Okay. So you need to find the fourth term. I think this one is straightforward. You can find the fourth term. Then the term which is independent of x, of A, will involve the stuff that we did. Alright, go. So first we find the fourth term. So when you find the fourth term, NC what? NCR is what?
3. Because R is 1 letter.
It starts very well.
Straightforward.
R equals. Okay.
Straightforward. Nothing to do.
Yeah, MC equals. Yeah, does that equal? 12 see something, right?
So the 4.
Oh, you like the record.
You like the record. I don't like
Yeah, you speak. Well, okay, this one. Not this one. These ones, they are legends. These are legends. Look here. Legends. Yeah. That one. And he still does his job. We are finding the fourth term. You understand? Okay. The moment you will calculate L plus 1, right? This here. This L plus 1, R plus 1 term. You are looking for the term. Which term were you looking for? So this is the general formula. The general formula is that. So the moment you are plugging in a 3, which you calculated, the moment you plug in a 3 here, that means you are looking for the fourth term. So effectively, what this is the fourth term. So when you are doing Pascal's triangle, the first term of this will be 12C0, blah, blah, blah. The second term will be 12C1, blah, blah, blah. The third term will be 12C2. This is 1, 2, third term. Then blah, blah, blah. The fourth term, which you are now busy, will be 12C3. It's always one less, right? Because that's the first term, second term, third term, fourth term. So when you are doing 12C3, first you have to find, okay, what is 3? Okay, using your formula, you know you're supposed to find the fourth term. So but 3, R will be 1 less than whatever the term is. Because look at the way they are. 0 here, first term, 1 here, second term. Can you see that? So now you're looking for the fourth. So what you're calculating is the fourth. So you still use the same, the rule, the general rule is the same. Where you have this.
Correct.
Why are you taking that off? No, it's fine. You can must calculate it. What is it? Wait, you want to calculate, you want to work it out already. Okay. Do you get the idea now? What you're actually doing, right? So when you are asked to find the fourth term, the eighth term, you follow what I mean? Then, R will be 1 less than that.
Always.
If
you're not told the term, you must tell.
If you're not told the term, then what are you supposed to do then? Then you need to find R. That means you need additional information that they will probably ask you which term contains the variable x raised to some power or a raised to some power.
Then you equate it to that power.
Then you equate it to that power. Find your R and then
plug it in.
Plug it in if you want to find the others. Okay? It's very easy.
If you find R, you can find the term.
Yeah, just do how you did.
Do you?
I should have.
Oh, okay. Nothing wrong with that.
I see.
But these are 8s, right? They look like 9s. Okay. That's the 9. Or you're making it smaller. Okay. That's fine. You got that one? What was it? Yeah, that is a negative.
It was a roll.
Huh? The 5. You also have a problem with 5. Like your sister there has a problem with 5. The 5 looks like the letter S.
Yeah? Serious problem. These things they follow you.
There you go. Now, they say the term which is independent of A.
I see.
So this was part A. Now you find the term which is independent of A. That means A raised to the power of
0.
0. There's a little bit of work there now.
Use it.
Okay? You tired? You don't want to do it anymore? Yeah? So, yeah, it's fine. But now you go, if you want to do, yeah. If you want to do the right thing, you say T sub R plus 1 equals to. Good. Now remember you are trying to find terms, so it's going to be 12CR or NCR. R is the one that you're trying to find. Okay? So all these things that we're going to do it. You can write 12CR or 12R. Okay, but why are you, we're not using this because we are looking for our R. Okay, now this question is independent of that. So we don't know what R is. That's why some people don't even write that NCR at the beginning. They directly go to the directly go to the A and the B. You understand what I'm saying?
They even take out the constants.
They even take already out the constants from the beginning. You see what I'm saying? Some people already immediately don't write this. They just go to that, 12 minus that, and that. You understand? To the R. Because the objective is you want to find those A's and write them in what you call it? Yeah, you get the idea. You did it a long way. Then you substitute it back in there. But E equals to what? Yeah. Minus R minus 4R equals to 0. Okay. Equals to 0. But actually becomes 0. R equals to 4. Okay. Now you know what R is. So you will have to plug this back, this value of 4 back in here, and here, and here. This was what you used, right? So you plug it back into the original. You follow. Just plug it. So just rewrite now. T sub 4 plus 1. Actually now we're going to be using the first term. Equals to 12C, your value. And then you just plug it in and you calculate now that. Because the question asks you, write down the coefficient, was it? In fact, what you are going to calculate anyway will be a constant. Is it not so?
Yes.
So the moment you don't get the constant, the moment you don't get whatever that variable is to that power, then you must know somewhere your algebra is a bit out. Okay? That means this part, you messed up this part. You follow what I mean?
It must be 7.
Angela. Okay. There we go. slightly different than how you did it in your book?
Show that.
It's more or less exactly the same. You got the same answer? The same? Okay.
Yeah.
Showtime.
Show that.
He says he wants to do 1 and 2b. In the expansion of, this is like very similar to the one I did in class now. You gotta just explain, understand?
3.
If she is not English, you can read the book and start. You're fine? All your hard work is about to disappear. But it's okay, you got it right in your book. That's all it is.
Another door is running.
You don't see this part right here. Huh? You see how it is.
Is that
Look at his
the
head. You have to do the whole thing.
Okay.
In the expansion of, don't make like you must bring your own. Write down the expansion. Faster people.
This is the question.
That's a what? That's a 9?
Yeah.
Why are you moving your head when you make that 9? Right, then you're supposed to find what is the first question asking? The fifth term or the sixth term. But you can do it here. Find the sixth term. Yeah, because you need that for other parts. Right? Okay, R plus 1 equals to what? So what will R be? Was 1 less, right?
Yes.
Do I need to like re-explain the concept why R is less?
No.
If you are asked to find the 7th term, then R will be 1 less than R will be. If you find the 20th term, R will be 90. Because when you are writing down, remember Pascal's triangle, blah blah blah, if you ask how many terms there will be, there's always one more term. So because there's always one more term, because first term has got that 0. So if there's one more term, so if you ask me the 12th term, then R will be 1 less than that. So there we are. This is why it falls under sequences. Can you see that? Because these are pairs. With a general term and stuff like that. So you see, he's ignoring all those 9CR in the constants, alright? But let me see something quickly. The reason that you have to leave that 1 is because the x square is a denominator. You understand? So the constant here is actually 1 over 2. That is the one that he took out. But x is still the denominator. You follow that? So he took out the NCR, blah, 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 and so on. 9 minus R. And that is R. So from here, it's just algebra should be solved. Then you don't have a problem.
I think I got made a mistake.
Yeah, and you're working. I saw that. I just didn't want to expose. But at least you are picking up on your errors. That is the most important thing. Right? That is why the way these questions are asked, you want to drill it into you so you can get it. And also remember your syllabus. You probably won't go this far. You won't get questions that go this far. Of course, this one is definitely one of those types. But the stuff that you'll see us now doing the other triangles, it's just adding more meat to the bone. You know, trying to sort of polish you as far as binomial theorem is concerned. Alright? If you look at the question they ask you in the specimen paper. So you need to be careful when you have 1 plus x, or in your expansion, there is a constant. If there is a constant, let's say, if there is a constant like a 1 plus x, 1 minus x, and they ask you about the variable x and it's written the other way around, you understand? Say the x is in front, x plus 1. Obviously you need to switch it because that x now must become your b. Before. Because it is 1 plus x and a plus b, where a can be anything with x like this, or other letter, and b can be anything with that. That is why I said yesterday you must go do this one here, and I said some stuff like this so you can get the idea. That specimen paper, quickly go to that question. I want to see how that.
The next one.
What was that expansion? This one, right? Yeah. The specimen paper was something like 3x minus 4 raised to the power of what? Of 4. And they're asking you find the coefficient of x. Do you see? This is not in the form of a plus b raised to the n. This is in the form a plus x raised to the n. This one is in that form. It's not so. Right? So what you need to do is you needed to swap them around and then you follow. That's why yesterday I said do this so you can get an idea, but this will just be whatever the coefficients of Pascal will come in front. That's very easy. Alright. So when you have some constant in there, the one term is like containing variables. Just know you ask where that constant, the term containing the variable is, because it needs to take the shape of the constant plus the term containing the variable. Are you still busy?
No, I'm just making
No, I
sure.
think his answer is wrong.
No, it's just.
Well, what's happening here? This is a 6.
It's supposed to be a 6.
Uh-huh. Uh-huh.
Okay, I see. Was there a 2 here?
You are the one who wrote this 2x squared. Yeah.
Oh, yeah, man. Yeah. Does it make sense?
Well, the answer makes sense, yeah, but what is that? What does that mean?
So I just dropped the.
You drop the x's.
Yeah.
Okay. It's a nice, interesting way of doing it. You know what he says? He says, that's what he says.
Drop
The what?
the x's.
Alright.
So, yeah.
Because there will be a constant term anyway. But you don't have to, you have to put it out there so you can work it out nicely. Please take one go drop things.
No need.
Great, you now understand the example, the specimen 1 and specimen 8. Yeah, it's slightly significantly different from everything that we have done. The working is still the same, right? Still the same general term. You just have to be careful with that. Did you put it on aeroplane mode? I thought you did. But people give you their books here. And I will tell you, these are the people who don't put any of this on. Alright, part B or part C of the question. It says the term containing x to the power 6. So you will go come back here. Then I do. Then you substitute it back into your. You get it now. Who's at home?
My sister and uncle.
Parents? They went for the weekend?
They
Wow.
took all the kids to the camping next week.
Yeah, so you get the rest of the little bit.
The answer was not indicated, there was one thing.
What answer was not indicated?
This one,
Part C. There's no answer for part C. There is. Huh?
I'll do it.
Well, there you go. You guys know your answers out of your head then. So they only have part A and B. Okay. So I like to start. So you can
Okay, so we're just continue.
do it. No. It's not that one. Will be off camera.
This one.
You can take this part of your first part.
I'm saying before
24 divided by 3 is 8.
I saw him.
And you are there with a calculator. That makes it so worse.
I was calculating something.
Because it was not in the book.
Yeah. I was wondering.
But what is that? A 2 or a 1?
Wait, here.
If that is 8, then how can that be 2?
Wait, here.
Yeah, what is that?
Oh.
Let's say.
Sorry.
It has to be 1, right?
Yeah, one. It should add up to man.
We know this, right? That is why I was asking this question.
Yeah, it's done.
Not easy, it was never easy. No pun intended.
Is it negative? You're positive.
Yeah, the one who. The answer will be positive because negative x raised to a positive index. A given index will be positive, no? That's half of 9. X to the power 4.5.
That's not a good subtraction.
And then if you write it as a fraction, it's 9 and 1/2.
What do you mean? Oh, what do you mean then? Oh, you multiply to
No, it's 4 and 1/2.
yeah.